All right, we'll get started. We'll continue by discussing bias variance trade-off. This is in chapter 2 of the text. And so the question we are interested in here is understanding what is the right model to use when we are given a certain data set. One approach we used last lecture for classification problems was to use techniques from VC dimension and bounce on the generalization error in order to study the complexity of a certain hypothesis class. But when it comes to regression problems, that approach is not very useful. The approach of bias variance trade-off turns out to be more natural in order to answer this question. And so this is what we will study in chapter 2, in this particular first half of this lecture. So here we are given a training set which consists of n samples. And what we do is we take the training set, we pass this through a learning algorithm, and we get out a hypothesis G. This is the output hypothesis. So for example, the learning algorithm might be stochastic gradient descent, which tries to optimize the parameters of our hypothesis class, which might be a neural network or a linear model. And once we run this, we get an output hypothesis G. So